In this video, I'm going to discuss about quadratic function or parabola graph. Quadratic function is given by f of x is equal to ax squared plus bx plus c. A, b, and c are called the parameters. We also call a and b as coefficients. And c is called the y-intercept. Parabola has two shapes that we are learning now here. When a is greater than 0, we call them as concave up. When a is less than 0, we call them as concave down. Yes. Now, about the intercepts. There are two intercepts, or one intercept, or no intercept. Now, this is the case of two intercepts. The graph will intersect the x-axis at two places called two intercepts. This is the shape of here is a concave up. This shape is called the concave up, going up. We also call them a smile. This shape here is called concave down when a is less than 0. And it's having two intercepts. You can see it intersects, the graph is intersecting the x-axis at 2 points. Now here, this is the case, this graph is a case of having one intercept. It's concave up is smile. It's concave up when a is greater than 0. So only one intercept. Look at this now. The turning point is on the x-axis. That's for one intercept. Here also look at this case. When concave down, one intercept, the turning point will be on the x-axis. Those two x-intercepts will meet at the turning point. Now, no x-intercept. So the graph for no x-intercept implies that the graph does not intersect the x-axis, no x-intercept. This is a concave up, and look at the concave down also, no x-intercept. So look at these three figures now. This is two x-intercepts, one x-intercept, and no x-intercepts for both the graphs concave up and concave down. So this is a very, very crucial understanding that we must have here. I hope clear. The earlier that we discussed here. So if you look at the range here, if you have to look at the range that we discussed, so range depends upon concave up or concave down. If it is concave up, all the values are above the turning point. All the values are above the turning point. That is why y greater than turning point. Here it is in the case of concave down, it is all the value, the graph is below this, all the values are less than. That is why we write y less than. Now come to the turning point form of the parabola. I discussed shape, intercepts, now turning point. Now only for the parabola, the three forms of a quadratic function. I'm talking only about parabola here. The three forms: standard form, turning point form, and intercept form. So this is my standard form. Ax squared plus bx plus is my turning point form. And f of x is equal to a times x plus p the whole square plus q is my turning point form. And f of x is equal to a times x minus x1, x minus x2. Here my x1 and x2 are called the x-intercepts. Now turning point I represent as x of tp and y of tp. In the standard form, how I find the turning point form, it is minus b over 2a. Is actually related to calculus as well as to axis of symmetry, but we'll discuss later. But x of tp is equal to minus b over 2a, and substitute that x into the original function, and then you will get the y value. That's how you find the y value of the standard form. And turning point form is directly you can write here. You change the sign of p is minus p and q right here. This is my turning point form. I can straight away write the turning point form. From the intercept, if I know the intercepts, how I find the turning point, x coordinate is given by x1 plus x2 by 2. That is the intercepts. The midpoint of the intercepts is my x coordinate, the turning point. And y coordinate, of course, I substitute in the original function here, and I find the y coordinate. Go back to our now let me give an example of how three forms are written. Here I have the graph of, here I have the graph of a parabola here. You can see that graph here, and my function is f of x is equal to minus x squared plus 4x plus 12. And now this is in my standard form. How do I find my turning point? That is, x coordinate of the turning point is given by minus b over 2a. My b is negative 4. If you look at your b here, my b is 4. Sorry, my b is 4. Therefore, I will write minus 4 over 2 times. And my a is negative 1. Coefficient of x square is negative 1. So I will write negative 1. And that will give me 2. How I find the y-coordinate turning point? Y-coordinate of the turning point, I substitute this 2 here into the original function, and I get the y-coordinate, and that is minus 2 squared plus 4 times 2 plus 12, and it will give me 16. So my turning point is 2 and 16, which you can see here, 2 and 16 is my turning point. 2 and 16. So I got my turning point as 2 and 16. Yeah, this program gives you extremum. We also call the turning point as also as extremum or a maximum point or a minimum point. But we'll deal with that later. That's how I find the turning point from the standard form. Now, from the standard form, we calculate the turning point 216. How I write the turning point form? TP form, as we discussed here earlier, it is minus, it is a times. Here my a is negative 1. Therefore, I'll retain that 1 here. So it is negative 1 times x minus my x coordinate of the turning point. My x coordinate turning point is 2. Therefore, I will change the sign and I will write as 2. So x minus 2 the whole square plus 16. So that's how I write the turning point form. Now, how I write the intercept form? If intercept form is, again, I look here and this, my intercepts are 6 and negative 2. You can see here 6 0 and negative 2 0. So again, I will write my a is negative. My a is negative 1. My a is negative 1. Therefore, I will write negative 1 times x. Here this is my positive 6. So I'll write as x minus 6 times x. This is my negative 2 is my x-intercept, so I write x plus 2. So this is how we write the intercept form. So 3 forms I discussed here. With an example, my standard form. From the standard form, I write the turning point form. From the turning point form, I can also write the intercept form. So we must know to interchange from one form to the other form. Now, another thing I want to discuss is here is the domain of the function here. So I'm going to discuss about the domain of the parabola. Domain of the parabola. Always domain of the parabola is x values are called the domain, x element of R. For a parabola, there's no change. Domain is always x element of x, can take any real number. Now, what happens to when it comes to the range? When it comes to range, be very careful here. When it comes to range here, again, we have to look into the shape of the graph. We look into the shape of the graph. If the graph is, if a is greater than 0, then it will be y less than, y will be greater than or equal to y turning point. If a is less than 0, y is less than or equal to y turning point. So here that is, no, in this case here we write range will be y. My range will be y less than or equal to 16. This is my range for this particular example. Now, the last point that I will discuss here is the axis of symmetry of a quadratic function. Axis of symmetry, that's what I will discuss now. Axis, if you look at this parabola here, and this line passing through the turning point parallel to y-axis, this line will divide the parabola into two equal halves. Therefore, I'll write this x is equal to, my axis of symmetry is x is equal to x coordinate of the turning point. X coordinate of the turning point. So that is my axis of symmetry.